Why can't you trust atoms? Because they literally make up everything. Good day, my beloved viewers. I'm Kuya Ems, and welcome to Lapis. This is episode 6 of our Agham Synthesis series, and today we'll talk about the smallest yet most powerful concept in chemistry: the atom, the building block of everything. When we hear the word atom, we think of something tiny. And that's absolutely correct. An atom is the smallest unit of an element that still retains the chemical properties of that element. Everything around us, air, water, food, gadgets, and even us, are all made of atoms. To make it easier to imagine, think of Lego blocks. Each Lego brick equals one atom. Put them together, boom! Whole worlds are built. Believe it or not, people have been thinking about atoms since ancient times. Way back in 400 BC, a Greek philosopher named Democritus said, "Everything is made up of tiny, indivisible pieces." He called them atomos, meaning uncuttable or indivisible. But this was just a thought. No experiments to prove it back then. Jump to the 1800s and John Dalton comes along. He was a chemistry teacher who built the atomic theory that we talked about last episode, which basically says that all matter is made up of atoms. Atoms of the same element are identical. Atoms of different elements are different. And atoms combine in fixed ratios to form compounds. That was the first real scientific step into the microscopic world. So let's talk about the evolution of the atomic model. At first, scientists thought atoms were just tiny solid balls. Turns out, it's way more complicated than that. In 1897, J.J. Thomson developed the plum pudding model. He discovered the electron, which is the negative particle inside the atom. He imagined the atom like a leche flan, positive pudding with negative raisins inside. In 1911, Ernest Rutherford did the gold foil experiment. He shot particles at gold foil and saw most of them pass through, but some bounced back. This meant, according to him, that atoms have a dense, positive center. He called it the nucleus. In 1913, Niels Bohr developed the planetary model. Bohr said that electrons orbit the nucleus in specific energy levels, like planets orbiting the sun. Today, we are now using the quantum mechanical model. Modern physics tell us that electrons don't orbit in neat circles. They behave like electron clouds with zones called orbitals. It's all about probabilities now. Every atom has three main parts. Proton is the positive charge inside the nucleus. This decides the element's identity. Example, 1 proton is a hydrogen, while 6 protons is a carbon. Second is the neutron, which has no charge, so it is neutral and also resides inside the nucleus. Neutrons affect atomic mass. Lastly, we have the electron. It has negative charge and it is outside the nucleus. Electrons are the reasons atoms react and bond. Fun fact, if the nucleus were the size of a basketball, the electron would be in the bleachers. That's how much empty space there is in atoms. Most of it is actually nothing. Next, let's talk about the isotopes and ions. Isotopes are elements that have the same number of protons but different number of neutrons. For example, we have carbon 12 and carbon 14. Both of them has 6 protons in total, but carbon 12 only has 6 neutrons, while carbon 14 has 8. Ions, on the other hand, are atoms that gained or lost electrons, making them charged. If it loses an electron, it's a positive ion, also called cation. If it gains an extra electron, it becomes a negative ion, also called anion. That's why we have electricity, because of ions flowing around. The power of the atom is everywhere. Photosynthesis. Plants make food by moving atoms around with sunlight. In electronics, our phones work because of tiny silicon atoms arranged in microchips. In medicine, radiation therapy fights cancer using atomic particles. In nuclear energy, by splitting atoms, we can generate massive amounts of energy. Some other crazy cool atomic facts. 99.9999% of an atom is empty space. Yet atoms build solid objects because of electric forces. The sun is a giant nuclear fusion machine, merging hydrogen atoms to produce light and heat. All matter in the universe comes from just 100 or so atomic building blocks listed in the periodic table. Helium atoms can become superfluids at extreme cold, climbing up the walls of containers. Lastly, lithium atoms power almost all of our modern gadgets, from phones to laptops. Quick recap. Atoms are the smallest units of matter. Inside it, they have protons, neutrons, and electrons. Atomic models evolved from plum pudding to nucleus-based to planetary to quantum clouds. Atoms make life possible, from food, gadgets, energy, to medicine. Lastly, if you want to understand the universe, you must first endeavor to understand atoms.
If you had fun or learned something new today, don't forget to like, subscribe, and click that bell icon so you never miss out on our fun new episodes. We've got more adventures coming your way. History, science, and math, all with a twist of nerdy fun. I'm Kuya Ems, and I'll see you in the next one.